When we gaze up at the night sky on a clear, moonless night, far away from the bright lights of civilization, we are treated to a breathtaking spectacle, a canopy of stars twinkling overhead. This awe-inspiring view is only a small fraction of the vast cosmos that surrounds us. The stars we see are just a tiny portion of the many stars that make up the Milky Way galaxy, our cosmic neighborhood. While the thousands of stars visible to the naked eye are beautiful in their own right, they are but a drop in the ocean compared to the hundreds of billions of stars that populate our galaxy. Beyond the Milky Way lie countless other galaxies, each containing billions or even trillions of stars. The universe, as vast as it is, stretches far beyond the limits of human comprehension. One of the most fascinating objects we can see in the night sky with the unaided eye is the Andromeda Galaxy. This neighboring galaxy, often described as a smudge of light in the sky, is the closest large galaxy to the Milky Way. Andromeda lies about 2.5 million light-years away from Earth, a distance so immense that it challenges our understanding of space and time. Despite its vast distance, it is the most distant object that can be seen without the help of telescopes or binoculars. Andromeda is often considered our sister galaxy due to its similarities to the Milky Way, but in many ways, it is much larger and more complex. Although the light from Andromeda has traveled millions of years to reach us, technology allows us to explore the universe in ways unimaginable just a few centuries ago. In a simulated journey that defies the laws of physics, we can traverse the cosmos faster than the speed of light. If we could embark on such a journey, we would leave our solar system in the blink of an eye. The planet that every human has ever lived on would quickly become a small, insignificant speck in the vastness of space. The sun, once the center of our world, would fade into the backdrop, blending in with countless other stars scattered throughout the Milky Way. To truly grasp the enormity of our galaxy, we would need to travel vertically, hundreds of light-years above the plane of the Milky Way. From this vantage point, we could see our entire galaxy in all its grandeur. The Milky Way, a barred spiral galaxy, is estimated to be about 13.6 billion years old. Its defining feature is its spiral arms, which extend outwards from the central bar and span a distance of more than 100,000 light-years. These arms are teeming with stars, gas, and dust, forming the intricate structure that we call home. Our Sun, although vital to us, is just one of hundreds of billions of stars in the galaxy. Current estimates suggest that the Milky Way contains between 100 billion and 400 billion stars, though the exact number remains uncertain. As we venture further away from the bright core of the Milky Way, we begin to see the universe beyond. In the distance, we spot other glowing objects. These are not individual stars but entire galaxies, each containing its own vast collection of stars, planets, and cosmic phenomena. The universe, rather than being random and chaotic, has a complex, organized structure. Galaxies are not scattered haphazardly but are grouped together in gravitationally bound clusters. These clusters, in turn, form a web-like structure, with immense voids of empty space between them. This cosmic web is one of the most remarkable features of the universe, a reminder of the delicate balance between matter and the forces that govern its movement. The observable universe is estimated to contain at least 100 billion galaxies, though this number could be much higher, potentially reaching into the trillions. These galaxies vary greatly in shape, size, and composition. Some, like the Milky Way, are spiral galaxies, with arms extending outward in a disk shape. Others are elliptical galaxies, more rounded and lacking the distinct arms of spirals. Still, others are irregular in shape, often the result of galactic collisions or mergers. Most of these galaxies are located at immense distances from Earth and can only be observed with the help of powerful telescopes, like the Hubble Space Telescope. However, there are some galaxies, like Andromeda, that are relatively close to the Milky Way and are part of a collection known as the Local Group. The Local Group is a cluster of more than 30 galaxies, all located within a region of space roughly 10 million light-years across. Within this group, the Milky Way is one of 3 large galaxies, but it is not the largest. That title belongs to the Andromeda Galaxy, which we are currently traveling towards in our hypothetical journey. Andromeda is a magnificent cosmic structure, named after the constellation from which it can be seen in Earth's sky. The constellation itself is named after the Princess Andromeda, a character from Greek mythology who was saved by the hero Perseus. Like the Milky Way, Andromeda is a barred spiral galaxy, but it is significantly larger, with a diameter of over 200,000 light-years, more than double the size of our galaxy. Andromeda contains an estimated 1 trillion stars, far more than the Milky Way. At its center lies a supermassive black hole, an object of immense gravitational power that governs the motion of stars and gas within the galaxy. This black hole, with a diameter of 516 million miles, 830 million kilometers, is larger than the orbit of Jupiter around the Sun. Its mass is estimated to be the equivalent of 140 million suns, making it far more massive than the supermassive black hole at the center of the Milky Way, known as Sagittarius A*, which contains only 4 million solar masses. The sheer size and scale of Andromeda's central black hole are awe-inspiring, highlighting the diversity and complexity of galaxies in the universe. Surrounding Andromeda are several smaller satellite galaxies, gravitationally bound to their much larger host. One of the most prominent of these is M110, a dwarf elliptical galaxy that orbits Andromeda. Although small in comparison to Andromeda, M110 is still a galaxy in its own right, with its own stars, gas, and dust. Just as the Moon orbits Earth while Earth orbits the Sun, these smaller galaxies orbit Andromeda, creating a dynamic system of motion within the local group. The interactions between these galaxies offer astronomers valuable insights into the behavior of galaxies over time, particularly in terms of how gravity shapes their structures and movements. Despite the vast distance between the Milky Way and Andromeda, these two galaxies are on a collision course. Both galaxies are moving towards each other at a speed of approximately 70 miles per second, 112 kilometers per second. In about 4.5 billion years, the two galaxies will begin to collide, merging to form a new galaxy. This event, while cataclysmic in some ways, will not necessarily lead to the destruction of the galaxies involved. Instead, the collision is likely to trigger bursts of star formation, as gas clouds are compressed and new stars are born. This period of intense star formation will transform the night skies of any future inhabitants of the galaxy, filling the heavens with bright, young stars. However, humans will likely not be around to witness this grand cosmic event. The collision between the Milky Way and Andromeda will take place long after our species has disappeared, either due to natural extinction or the inevitable changes that will occur as the Sun ages and expands into a red giant. Yet, even though we may not see the merger, we can still appreciate the beauty and grandeur of the universe as it exists today. By looking up at the night sky, we can catch a glimpse of Andromeda, the only object visible to the naked eye that lies outside the Milky Way. And in doing so, we can reflect on the fact that, one day, this galaxy will merge with our own, forming a new galaxy that some have already named Milkomeda. The future Milkomeda galaxy will be a testament to the ever-changing nature of the universe. Galaxies, while seemingly eternal, are constantly evolving, shaped by the forces of gravity, dark matter, and dark energy. Over billions of years, galaxies collide, merge, and grow, creating new structures and star systems in the process. The merger between the Milky Way and Andromeda is just one example of this cosmic evolution, a reminder that the universe is far from static. Even on the largest scales, the universe is in constant motion, with galaxies interacting and influencing one another in ways that continue to fascinate astronomers and cosmologists. Our journey through the cosmos would not end with the local group. Beyond this small cluster of galaxies lies the Virgo supercluster, a much larger collection of galaxies, including the Milky Way, Andromeda, and many others. The Virgo supercluster spans a region of space more than 110 million light-years across and contains tens of thousands of galaxies. But even this vast structure is just one part of the larger Laniakea supercluster, a gargantuan web of galaxies that stretches across 520 million light-years of space. The scale of these structures is almost impossible to comprehend, yet they are an integral part of the universe's overall architecture. As we continue to explore the cosmos, we uncover more about the forces that shape galaxies and drive their evolution. Dark matter, an invisible and mysterious substance, plays a crucial role in the formation and behavior of galaxies. It acts as a kind of gravitational glue, holding galaxies together and preventing them from flying apart. Without dark matter, galaxies like the Milky Way and Andromeda would not exist in their current forms. Likewise, dark energy, another mysterious force, is responsible for the accelerated expansion of the universe. This force is driving galaxies apart, creating the immense voids between galaxy clusters and shaping the large-scale structure of the cosmos. In summary, the universe is a vast, intricate web of galaxies, stars, and cosmic phenomena, constantly evolving and changing over time. The Milky Way, our home galaxy, is just one of billions of galaxies in the observable universe, and it is on a collision course with Andromeda, its larger and more massive neighbor. This merger, while far in the future, will create a new galaxy and transform the night skies. Yet, even as we contemplate these distant events, we can still look up at the stars and marvel at the universe as it exists today, a reminder of the beauty and mystery of the cosmos.